So when you're looking at this, again, the first thing I would do is to just kind of sketch what gives us the shaded region. So if I took a triangle and I subtracted the circle from the middle of it, I'd be left with the shaded region. And then find the area formulas associated with those, 1/2 base times height minus pi r squared. I can then go in and identify what I have. So when I draw in my altitudes here, which are also medians, this intersection is going to be every point of concurrency, so it is going to be the centroid. And so when I find, because it's an in-center, I know that this is a radius of the circle. Well, if the circumference is 12 pi and circumference is designated as d pi for a formula, dividing both sides by pi, I get my diameter to be 12, which means my radius is half of 12, or 6. Okay, and so I know this part, so pi times 6 squared, I have that portion of it. Okay, and if this is 6, then I know that this portion here would be double that, or 12. So my total height is going to be 12 plus 6, or 18. And what I can now do in this 30, 60, 90 triangle that's created here, if I know my height was 18, or the side opposite 60 degrees, I can find what the leg opposite 30 degrees is by taking 18, divide by 3, and multiply by root 3. Okay, I could have also done it the following way. I could have taken and connected this portion here. When I connect that portion here, I get this hypotenuse of 12. This is a 30, 60, 90 triangle now flipped on its side. So that means that this portion would be half of that 6, and this portion would be 6 root 3. So I can do it either way. Either way I do it, I get my calculation 1/2 the base. This whole length here is 6 root 3 plus another 6 root 3, so 12 root 3. The total height of that triangle was 18. And so if I calculate this, half of 18 is 9. 9 times 12 is 108. Carry along the root 3. 6 squared is 36 pi. The units are inches. It's an area, so it's two-dimensional. And so this would be my calculated value.